So we're going to use Excel in order to take up this question, and feel free to use Excel if you've got to do any kind of calculations where it's very repetitive, such as this type here. And so for the mean, this is equal to the average of these 6 data values. And as we saw before, it comes out to be 39.3 repeating. Now, to calculate the x minus x bar, which is our data value, which is found for the first one in C4, so 34 minus, and we're going to put in H3, but I want to make this a global reference so that when I copy the formula down, it references that particular cell which has my mean in it. So now if I copy this down, this is what you should have got for your values. Now, I'm going to use a function, so for calculating the square, this value squared. So all it is D4, which is my value of x minus x bar for the first calculation. And I'm going to press Shift 6, and I get then negative 5.3 repeating squared is equal to 28.4 repeating. So now all I have to do is copy all of this down, and it carries the calculations through. So if I want to add up this particular column, there's a couple ways I can do this. So sum is my sum function, and just highlight the values and press enter. And so this value of, now this is the sum of x minus x bar squared, is equal to 67.3 repeating. All right, so I pasted my results over, and you'll notice again we have the data values minus the mean, and then we've taken that value and squared it. Down here we have taken the sum, so the 67.3 repeating is the sum of all the data values minus the mean squared. So this column is all the data values minus the mean squared, and when we add these all up, this is our result. That's what that is doing. So when we go to our formula for variance, now variance is equal to the sum of the data values, sum of the squares of the data values minus the mean. And from up above, this is our 67.3 repeating divided by the number of data values that we've taken. So in this case, we're making the assumption that if we're considering the day as the population, so we're just looking at this particular day, then we can use n. And so this is equal to 6. And so when we calculate our variance, this is 11.2 repeating. And so down here, standard deviation is going to be then the square root of our variance, which is the square root of 11.2 repeating, which is equal to 3.35 approximately. So that means that the variation from the mean, the standard deviation, is 3.35. So now we're going to compare the results or the variance of the standard deviation of Felix to those of Melanie to determine who is more consistent. So if we take a look at, and I've filled out this table, and you can check your answers with what I have. So the mean for, in this case, for Melanie was 41. So 51 minus 41 is 10. Square 10, you get 100. Continued these calculations down. And so the sum of x minus x bar squared is equal to 328. So now this is equal to 328 divided by 6, which is equal to 54.6 repeating. And the standard deviation will be equal to the square root of the variance. So it's the square root of 54.6 repeating, which is equal to approximately 7.4. So now, if you recall, Felix had a standard, this is Melanie's standard deviation. And Felix had a standard deviation of 3.35 approximately. So from this information, our concluding statement's going to be then, or conclusion, is going to be Felix has a smaller standard deviation, therefore he is more consistent.